Okay, so as far as the grading plan, like I mentioned, there's actually two main components before we start the grading plan. The first component is our survey. This is the before, I guess we can call it. So whenever we start a grading design, we need to know what's there before. And what I mean by what I'm looking for is vertical and horizontal information. So what we start with is we start with a plat. You can kind of see property lines. You can see a right of way right in here. You can see a center line. So the surveyor gets the plat of this area. Of course, it's not the full plat. It's really just platting or drawing out the lines just for that one lot that we're going to be working with. So this is our main property line that we're working with. When they're survey, they also get some information that's adjacent to us, next to us, because that's information. We need to know that. And we need to know that because when we're designing our building, we need to see is there anything we need to worry about? Is there something we need to consider next to us? Is that building, how close is it? The elevations of the pavement on the other side. Is it parking area? Is there a sidewalk I need to worry about? What about the existing roadway? So I need to all know all of these things so that I can better develop my site to make sure I have the right access, the right driveways, and all that stuff. Okay. So before we do anything, the surveyor has to go out there first, collect the data of what's there before the project begins, and before we start design, and then that's what we'll be getting this file here. So then this is the file we'll get, and then after that, the architect should, and here's a key word, should, on the site plan, the architect should use the topo, the property lines, to then develop their architectural site plan. So the architect, if you notice, is the one that's going to tell us where they want their sidewalk, where they want driveways, where they want the parking areas, any islands, maybe light fixtures, rock walls, where the building is at, the shape of the building. Now, I say the word should because I'll tell you right now, there's some architects that don't. And we're gonna the way we're gonna approach this project is me, Mr. Torres, is gonna be the quote unquote designer. So what I do as a designer is I take the topo from the surveyor. I then take the architectural site plan and I mesh them together to start developing the grading plan. Okay. So if you notice on the grading plan, it's actually both things together, both the survey and the architectural site plan all together. Okay. What you're going to draw in is really just the contours. So this is really the only part you're going to draw in is all the contours. You're going to draw in the spot elevations, and that's all based off of the design that they're giving us in a hard copy. Okay. So the purpose of this assignment is I'm going to show you guys how to import these contours, and we're going to use these elevations and put them in as spot elevations to start developing our formal grading plan, which is going to look like this. Okay. But I took off the background information just to kind of show you what eventually you guys are going to be drawing. But as far as the topo and site plan, those are the two different things that the designer gets from, like I said, the architect is the one that develops the site plan, and then you get the topo from the surveyor. Okay. Now, this is where it gets kind of interesting because I think we mentioned several times the friendly competition between architects and engineers, and that sometimes the architect doesn't draw their site plan based on an actual topo. They sometimes don't know the actual property line, and this is what the property line is. And sometimes the architects don't know what that is exactly, so they just kind of come up with a site plan. You put them together, and they don't fit. So the designer then has to call the architect. Hey, your site plan is not working. Well, why not? Well, it doesn't fit on the topo. What topo? Oh, well, there's a topo with property lines. Really? I've had that actual conversation with architects. Not many of them, but it has happened before. So again, that's why you as the civil engineer needs to use the real topo. You have to use the one with the actual property lines, and hopefully the architectural site plan fits. And sometimes it doesn't. Sometimes you put it together and you got a parking lot that's maybe sticking into the next door over here, or the driveways down the line, or just all kinds of things could happen. But nonetheless, that's how that works as far as why we have that little competition between architects and engineers. because they use different uh, methods of developing site plans and stuff. But here in our class, that's what's nice about for you guys, that you're understanding, hopefully, the difference between a survey, how to use a survey, and what is a survey. Of course, the survey shows plats, easements, property lines, right of ways. But the other thing that we have added in here is also elevations. Okay, so we also have vertical elevations of the site. So TC is top of curb, G is gutter. We have a sidewalk elevation. Okay. Um, and this is something I haven't explained yet, but as far as the elevations, this is the actual elevations of this site. And like I mentioned, this is a project that's on the east side of El Paso. I changed names of streets because I really don't want to infringe upon an engineer's work. So I'm just kind of changing names. But it is a site in El Paso. And I will tell you, those are elevations that are in this region. So in other words, this is 3890, 3885. So kind of weird, but a lot of people don't know that. But on the east side of El Paso, you're at about that level above sea level. Okay. So the east side of El Paso, about 3,885 feet above sea level. If you're here at Riverside High School, the elevation here is approximately 3,600 feet above sea level. Okay. If any of you guys are over there by El Dorado High School, way up there on the east side, those guys are about 3,900 feet above sea level. Okay. And I don't know if anybody lives on the west side over there by Franklin High School. Those guys are even higher. Those guys are about 4,200 feet above sea level. So it's kind of funny that if you drive from Riverside High School all the way to Franklin High School, you're actually going up about 600 feet vertically in elevation. That is kind of crazy, but a lot of people don't know that. Okay. So here in El Paso, it's kind of interesting. We're actually pretty high up there as far as elevations. Okay. Different parts of town are different heights of elevation, but we are higher in elevation. Okay. I did a project one time in San Antonio, and I'm used to 3,800, 3,900. The first time I did that project in San Antonio, I got the topo and I was getting elevations like this. I'm like, 500? Really? Yeah, San Antonio is only about 500 feet above sea level. So that's kind of interesting. I remember when I went to go visit a friend of mine in Houston. Okay. And in Houston, I did a project, and there was a couple of areas that were actually negative. And I'm like, okay, what is that all about? It's actually below the level of the sea. Okay. So that's over there in Houston. Where is Houston? Right by the ocean. Okay. So, just to kind of make some reference as far as elevation. So up here in El Paso, we're at about 3,800 for this side, and here in the lower valley, about 3,600. And it can go up to about 4,200 feet above sea level here in El Paso. So just a little bit of a reference. Okay. So as far as all these elevations, we have a 3890, we have a 3885, but if you notice, these elevations say 85.9, 88.4. It's still the same as saying 38, 88.4, 38, 85.9. So all of these have 38s. It's just that we don't put in the first 38 because we just don't need that text. We understand this whole area is 3,800 feet above sea level. So it's still understood as being 3887.2, 388608 in elevation. Okay. So that's why you see that a lot. We do that a lot in our plans, even in the final grading plan. If you look at our spot elevations, they all say 89s, 90s, 88s, yet we're still at 38, 90. So still 38, 89, 38, 89, and things like that. And they are in 3D. Okay. So what we're going to be doing in the first part of our grading plan is put together the topo that comes from the surveyor, which is in 3D, together with our contours, which are proposed contours, which are the ones in yellow, and we're going to set them to the correct elevation. Okay. I just want to make sure you guys understand what we're going to be doing with this grading plan. Okay, let me flip this around. All right, so that's going to be the ultimate design. And in trying to explain this design a little bit more, we have elevations. For example, let's see, where do we have a contour that's labeled? We got an 85 elevation here, yet we're calling for a pavement elevation of 89. So in this area, it's almost like we're filling from the existing grade of 85 up to 89. We're filling about 4 feet of dirt in this area. Okay. And why are we doing that? Why don't we just leave it at 85? Well, the thing is that we got a building. We got a building, and the building elevation that the engineer decided to use is 9083. The elevations over here on this road is about 92. Way down here, it's about 83. So this road is actually dropping in elevation quite a bit. So because of that, the engineer decided to kind of put it más o menos in the middle, and where it's nice and accessible off. If you drive off the roadway here, you're not having to climb or drop in elevation, anything crazy. It's just very comfortable, and you're able to park your car here. This one is 80, 90, 89, 88 elevation. You're going to go from an 88 elevation up to a 90, so you're only climbing about 2 feet. So it's nice and comfortable. Okay. And that's the purpose of the civil, and what we're doing is we want it to be comfortable, meaning you park your car, you're able to get off nicely and walk up to the building and do whatever you're going to do at that building. Okay. So that's good design. And in here, like I said, here we're filling about 4 feet somewhere down here. This is 82. We're up to 86. So yeah, we're filling about another 4 feet or so in this area. All right. Which is why, if you look at the, and these are pictures of the site during construction. Okay. So this is before anything. So during construction, you can kind of see where the building is going. And then we go down a little bit on McKinley. You can kind of see the difference in elevation as it's dropping from here all the way to here. But over here, it's kind of flat. So that's why you can see the difference in elevation here. And that's about the 4 feet of difference that we're talking about. Okay. So that's where that comes from. And here, standing on the corner, you can see how much we're actually having to fill. Once again, that way you can park your car up in this area and walk up to the building nice and comfortably. Okay. Now, in some cases, we do have clients that tell us, no. Why are we filling all this stuff? That, by the way, is very expensive to do all this fill. And then we have to do this, what's called a retaining rock wall, which is a structural rock wall. We're talking, tens of thousands of dollars. So sometimes they say, no, don't fill this. Just kind of leave it at existing grade and just kind of, grade it from here all the way up to the building. Well, that's not a good design. That's not a good design. And, it's just, this is what's better, just so that the site works better. Okay. Is there such a thing as bad design? Yes, we have bad designs here in El Paso, several of them. Let me show you a couple of things that you don't want to do. Okay. Let me show you a couple that I know of here in El Paso. Let's see. I know one for sure is over here on Yarborough and Vista del Sol. Yarborough and Vista del Sol. Okay. There's a Wiener Schnitzel, and let me turn on the satellite view. There's a Sonic right in here. I don't know if anybody's ever been here. Let me kind of go this way a little bit. Okay. So here's Yarborough. There's a Whataburger here. This is Vista del Sol. This is the area I'm talking about right here. I don't know if anybody's ever seen that area. Okay. Let's go up here real quick. This area is a very bad design. I'm not sure how they even allowed it to be built. But look at this thing right in here. Okay. I'm not sure if anybody's gone to this massage parlor, but whatever. Just look at this right here. That is very hard to even park your vehicle. Okay. That is so inclined that I'm not sure anybody even parks there. Or if they can, I'm not sure how you can even get off your car safely. You'll struggle getting off your car. Okay. So that's what I'm saying. You can have bad designs, and they happen all the time. I'm not sure how this even got built, to be honest with you. But there is such a thing as bad design here in El Paso. That is a good example of bad design. Okay. What could have happened here? Well, maybe instead of putting these parking stalls, maybe they should have just not put them. and maybe put them over here instead. I don't know. So we got two stalls here. We could have put them over here. I don't know. It's just these are things that we try to avoid because it's not going to work or it's very uncomfortable. It just, try it sometime. One of these days, if you're out with your parents or yourself, try to park here one of these days. It's right there on Vista del Sol and Yarbrough. You'll have a hard time even just parking your car here. Okay. So that's an example of bad design. Okay. Strangely enough, I know of another one kind of in the same area right here by Bel Air High School on Corral Drive, right around here. Oops. Actually, it's that building right over here. Okay. Look at this corner right here. Okay. This is pretty steep. This is pretty steep. So here, just parking your car here, that's getting pretty uncomfortable. Okay. Now here, this is kind of, in my opinion, a bad design because what keeps you from driving your car through here? Nothing. I think if you were to drive your car through here, I think your car would actually tumble and roll over. That thing is really, really steep. Okay. So honestly, I'm not sure why they even allowed this. What should have done is you probably should have built like a nice retaining rock wall here. And then instead of sloping all the way to the bottom, slope to the top of the rock wall. And that way you don't have a huge, huge drop in here. Again, it's a bad design. Okay. It's a bad design. Those are things that we try to avoid. Sometimes you have the client that doesn't want to build a retaining rock wall because it's expensive. No, no, no. Just do whatever you need to do. But that's, those are things that you try to avoid. Those are things you try to avoid. Okay. So nonetheless, on our design, by doing that, we're actually going to lift this area here in the corner. And, like I mentioned, we are not designing this ourselves, but this is what the engineer has decided to do. I think it's a good design. I think it works well. Yes, we have to build a rock wall to make the elevation on the other side a little higher than this side. Okay. So ultimately, that's the grading plan that we're going to try to accomplish.